Hi students, Lesson 9 focuses on ocean study using modern ships. These studies generally are cooperative efforts between nations and institutions. The reason for this is because they're very complex, large scale quite often, and expensive. Typically they're led by scientists from the United States. These ship-based studies use ocean-going vessels to collect a wide range of ocean data. So let's talk about some of this. Ships outfitted with drill rigs can drill into the ocean floor, and in so doing they remove samples of sediment and rock for study in ship or land-based labs. Classic example, back in the late 60s, beginning then, deep sea drilling project. And that transitioned into the ocean drilling program that started in 1985 and continues to the present. So these are both large ships fitted with onboard drill rigs. They were sent out to gather core samples of rock and sediment from the ocean floor. So on the lower left, we have the Glomar Challenger, and you can see the drill rig on that. Challenger wasn't a very large vessel, and it was not specifically designed for this purpose. So it did its job gathering core samples, and then eventually gave way to a much larger, more modern vessel, the Chikyu, which is currently being used for the ocean drilling project. And you can see the Chikyu has a helipad, has a huge drill rig, and some large cranes and other devices for gathering data from the ocean floor. These core samples, once they're brought up to the surface, are carefully analyzed, looking for history of the ocean life in terms of the fossils contained within the cores, information about the formation of ocean basins, current circulation, and also the distribution of natural resources. So on the lower left, you can see actual work on the drill rig. It's very dangerous work, especially with the vessel constantly moving on the ocean waves. And on the right, that's an onboard laboratory on the Chikyu with earth scientists analyzing the cores that have been brought up from the ocean floor. Another approach, using ships that deploy buoys. There are many variations on this approach. Ships will typically deploy a series of buoys, and those will then send data via radio signals to the ships or perhaps to land-based receivers. And the photograph shows a typical buoy bobbing in the ocean. It's got multiple sensors. It's got its own energy source, a battery pack, and it can transmit radio signals quite a distance. Since the 1950s, these buoys have measured ocean currents and waves, as well as temperature and chemistry of the ocean. So here's an example of a wave buoy. And of course you want to stay clear, these things are quite large. So wave buoys are used to gather data about the direction and size of waves on the ocean. That diagram on the right shown here is a Scripps Institute wave map. And these are used to analyze waves as they move ashore along the coast of Southern California. So if you look at this diagram at the bottom, you have sizes of waves. These are in feet. The black, 0, so relatively flat, and the black here is shown as land, so no waves on land. Then the waves can get much larger. The largest waves, it looks like, were in the yellow on this particular day. Those were 6 to 7 footers. If you come close to the coast of Southern California, off to the right there, coast is in black, you can see we get quite a wave shadow effect. So the waves that finally make it ashore to our coast are quite a bit smaller than they are out on the open ocean. We'll talk about that wave shadow effect in the future. Data gathered from thousands of buoys over many decades has been used to develop cross-sections, or what we call profiles, of the ocean. These are essential for understanding ocean physics and chemistry. So we'll consider the World Ocean Circulation Experiment and look at a number of these profiles as we go through the course together. So here's a really wonderful profile. This is Pacific Ocean salinity, south to the left, north to the right. And this covers thousands of miles, and what you're looking at in the brown is very salty water, and as you go deeper, you have reduced salinity. We'll talk about the effects of evaporation from the sunlight and from the freezing of ocean water, turning it into ice, and how that makes the ocean saltier, and how then the ocean currents can move around this salty water. So this is a great snapshot view of ocean salinity based on buoys and the data they collect. Sound is also useful. Scientists are trying to determine if the ocean is warming as the atmosphere warms. You've heard of global warming? Well, here's a tie-in. This is due to the emission of greenhouse gases like CO2 from human activities. Turns out that the ocean changes temperature very, very slowly, so increased temperature of the ocean will be very small compared to that of the atmosphere. And the reason for this we'll discuss in the near future. It's related to the ocean's high heat capacity. So to detect a minor temperature change in the ocean, you can send a sound or acoustic signal through the ocean and let it travel over a great distance. To do this, to broadcast this sound, you can lower a loudspeaker over the side of a ship. Sometimes these are just planted on the ocean floor, or you can drop explosives from a ship, kind of like the depth charges used to destroy submarines in World War II. The Acoustic Thermometry of Ocean Climate Experiment, we'll use the acronym ATOC, applied this technology to study the possibility of global warming. So here, receivers at various locations in the Pacific Ocean picked up sound from a distant location. And then the velocity of that sound was measured with great accuracy. So here we have a map showing the ATOC. Focus in toward the lower middle of the map. Kauai, one of the Hawaiian islands, just off the coast of Kauai, was a major sending area for sound, and that was sent out into the North Pacific Ocean. Those red dots represent receiving stations. So they were able to receive that sound, very carefully measure the velocity of the sound, and that would tell us if the ocean is warming. So if the velocity of sound in the ocean increases, then that suggests the ocean is warming. What's the connection between increasing sound velocity and the warming of the ocean water? Here's the logic. Turns out that warmer water has more energy, so it communicates sound more efficiently than does colder water. So if the water is warmer, sound travels faster.